Hello, welcome to the another lecture on this course on modeling, analysis and estimation of three-phase unbalanced power networks. We have been talking about the rotation matrix and their effect on the matrices. So, then we have been looking at the effect of pre-multiplying as well as the post-multiplying of these matrices by various matrices. So far in the last lecture, at the last we have done this, that we have seen that when we are essentially pre-multiplying r phi inverse to any vector or to any matrix, the effect is that the first row come to the third position, and then the second row goes to the first position and the third row goes to the second position, right. So, therefore, now we have been doing this. So, then therefore, if we now combine all these two, so then we have this equation. So, that r phi inverse V A B C is equal to r phi inverse Z A B C into I A B C. So, then therefore, if we now collect all these results and then write them in a matrix form, so then what I get is that VB, VC, VA is equal to ZBA, ZBB, ZBC, ZCA, ZCB, ZCC, ZAA, ZAB, ZAC, that would be equal to IA, IB, IC. So, this would be the case. So, here you see that the third row has or rather the first row has come to the third position, and then similarly. So, then from here, as an example, if we write down the expression of say B, so then from here the expression of VB is nothing but ZBA into IA plus ZBB into IB plus ZBC into IC, and this expression is nothing but the original expression of the voltage VB, right. So, then therefore, again by this manipulation the original expressions of the various variables, they are get preserved, right, they are preserved. Now, let us see that what happens if I now basically proceed further. So, then let us see what happens. So, we can now write that r phi inverse V A B C is equal to r phi inverse Z A B C into I A B C, right. That I can write down as r phi inverse V A B C is equal to r phi inverse Z A B C into r phi, and this I basically pre and post multiply by r phi inverse I A B C, right. Now, let us see what happens to r phi inverse into Z A B C into r phi. So, we have now r phi inverse Z A B C into r phi. Now, R phi inverse into ZABC, we have already seen that it is ZBA, ZBB, ZBC. So it is ZBA, ZBB, ZBC, and then ZCA, ZCB into ZCC, and then ZAA, ZAB into ZAC. That into R phi, right? And my R phi would be nothing but the transpose of, so it would be 0 1 0 0 1 0 and then 0 0 1 0 0 1 and then it would be 1 0 0 1 0 0, right? So this is basically R phi, and this is R phi inverse into ZABC. So we have already proved it in the last slide. So then therefore what I get is that ZBB, so it is ZBB, then it is ZBC, and then ZBA, and then it is ZCB, and then it is ZCC, and then it is ZCA, it is ZAB, then it is ZAC, and then it is ZAA. Right? And we have already seen that R phi inverse, and also we have already seen that R phi inverse VABC is basically VB VC VA. It is VB VC VA, that you have already seen also. So then therefore if I now write these equations in a matrix form, so then what I will get, and then of course R phi inverse I ABC also would be IB IC IA. So then therefore if I now write everything in the matrix form, so I get VB VC VA, that is equal to ZBB ZBC ZBA ZCB ZCC ZCA. So here again just note it down. So this is nothing but R phi inverse into VABC, and this is nothing but R phi inverse into IABC, and this is nothing but R phi inverse ZABC into R phi, right? So again, from here, if I now write down this equation for VC, VC is ZCB into IB plus ZCC into IC plus ZCA into IA, and this is nothing but the original expression, right? So this is equal to the original expression. This is nothing but the original expression. So then therefore the expressions, they do not change, only the um, alignments of the rows and columns and everything, they do get changed. Other than that, nothing essentially changes. So then, so far we have looked into the three cases, that basically pre multiply by R phi. We have also looked at post multiplication by R phi inverse. We have also looked into pre multiplication by R phi inverse. Now let us look into that what happens that if I do post multiply by R phi. Now what has happened by post multiplying by R phi? For example, here. So I mean, this is basically the case for your post multiplication by R phi. So then therefore this is a matrix R phi inverse Z into ABC, and this is, we are simply trying to post multiply it by R phi. So you see, so basically this is the original matrix and this is the final matrix. So then what happens here? It happens that this column first column goes to the third position. You see that this column has gone to the third position, and then this column comes to the second position, and then this column comes to the first position, right? So then therefore, just to look at it, if I now do, let's say, do ZABC also, if I now post ZABC into R phi, so what it will give me? So it is ZAA, ZAB, ZAC, ZBA, ZBB, ZBC, ZCA, ZCB, ZCC, and R phi is 001, 0, 0, 1, 1, 0, 0, 0, 1, 0. So it becomes ZAB and then ZAC and then ZAA, ZBB, then ZBC, then ZBA, ZCB, then ZCC, and then ZCA. Right? So you see here what happens? Here basically happening is that this is the first column, it has gone to third position, right? And then this third column, it has gone to second position, and then this second column gone to first position. So then therefore, just to, so it has gone, so this has gone here, and then this has gone the first position, and this has gone to the second position, right? So then therefore, if I look at it from this, so then therefore, so these are the three columns. So these are the three columns. And these are the, so these are the three columns, right? The effect is that the first column goes to the third position, and the second column goes to the first position, and the third column goes to the second position, right? So that is the effect of, so it is the effect of post multiplication by R phi. So this is the case. Now we have already seen the other three cases. So just to summarize, let us also write all these cases again in the next slide. So then therefore, from henceforth we would be able to refer to this. So then this is the case is, let us say, post multiplication by R phi. So let us say that this is case 1. So then what is the effect of pre multiplication by, so this is the effect of, so pre multiplication by R phi, that would be basically, so basically it would be, it is the row. So these are the row. So in the pre multiplication of the, so basically third row goes to the first position, and then first row comes to the second position, and the second row comes to the third position, right? So this is the pre multiplication by R5. So this is a row operation. This is a row operation, right? And when I post multiply, this is basically a column operation. right. So, when I post multiply by R5, it is a column operation. Now, let us see that what happens by pre multiplication by R5 inverse. So, pre multiply by R5 inverse means, so it is the case is, so this is the case. So, pre multiply by R5 inverse means that I have again 3 rows. So, this so this is the case. Right. So, what happens to pre multiplication by R5 inverse? It is first row goes to the third position. So, first row goes to the third position, and then third row goes to the second position, and second row goes to the first position. So, this is also a row operation, right. And as you can see that basically the pre multiplication by R5 and pre multiplication by R5 inverse both are row operation, but the effect is just the reverse, right. So, then therefore, here the effect is just the reverse, because in the case of pre multiplication by R5, here the third row goes to the first position, but when I am doing the pre multiplication by R5 inverse, here the first row goes to the third position. So, it is just the reverse. So, then therefore, whenever we are doing pre multiplication, it is a row operation, right. And we have already see what happens that whenever doing post multiplication by R5, let us see what happens. Let us again recollect that post multiplication by R5 inverse. So, post multiplication by R5 inverse, it is would be basically, so it would be basically right. And what happens that here third column goes to the first position, and then the first column goes to the second position, and the second column goes to the third position. So, it is also a column operation. And you see, and if we compare it the case with post multiplication by R5, what we get post multiplication by R5 is that first column goes to the third position, but here post multiplication by R5 inverse is third column goes to the first position. So, then therefore, they are just reversed. So, then therefore, the conclusion we can draw two very important conclusion. One, pre multiplication pre-multiplication by R phi or R phi inverse affects row operation, right? And the effect of, and whereas post multiplication by R phi or R phi inverse affects column operation. So this is a very important observation and conclusion, right? And the second is also equally important, that the effect of R phi and R phi inverse, effects of R phi and phi inverse are reverse to each other. This is very important conclusion. So these two are very, very important conclusions, that when we are doing pre-multiplication either by R5 or by R5 inverse, we are actually affecting row operation, whereas when we are doing post multiplication either by R5 or by R5 inverse, we are doing column operation, and the effect of R5 is essentially reverse to the effect of R phi inverse, whether it is basically a column operation or a row operation, right. So this concludes our discussion on the rotation matrices. From the next lecture we will now look into that how these rotation matrices can be used to calculate the impedance matrices for any transposed transmission line. Thank you.